In this section, we change from working with expressions to working with equations. The entire difference between an expression and an equation is the fact that an equation has an equal sign. In order to evaluate an equation, we need to use all the skills that we already learned in this unit. So being able to simplify, multiplying, dividing, adding, and subtracting is probably the most key skill, because we're going to have to do some adding, subtracting of some fractions. So the first example says we're going to solve. Well, when we talked about quadratics, when we solved, we had to get one side equal to 0. Then we're going to state the non-permissible values, and we're going to check our answers. Well, in order for us to solve this, the first thing we need to see is that we have technically 3 fractions. We have x over 4 subtracting 7 over x equaling 3 over 1. Now, in order for us to add or subtract these to get one side equal to 0, we need to get that common denominator. What we'll see is that in this fraction, in this rational expression, we have a 4 in our denominator. In this one, we have an x. And in this one, we have a 1. So if we want to look for a common denominator between 4x and 1, the easiest way would be to multiply them all out. 4 times x times 1 is 4x, which means the only thing that this rational expression is missing is an x. This rational expression is missing the 4. And this rational expression, because its denominator is 1, it would need the 4 and the x. As soon as we get to there, then we just do our multiplication by that funky form of 1. X by x is an x squared. A negative 7 times 4 is a negative 28. The entire denominator is a 4x. Then we have the equal sign. So on the right-hand side, we have a 3 and a 4x in our numerator. Well, 3 times 4x is 12x. 1 times 4x is 4x. And now that our denominators are the same, we can subtract this to get one side equal to 0. And it would be ideal to subtract this entire 12x over 4x because this already has a positive x squared. Typically in pre-calc 20, we want to have positive x squareds. Now a 12x over 4x, subtracting a 12x over 4x, on the right-hand side we would be left with a 0. On the left-hand side, since our denominators are already the same, we just have to add across the top. And ideally, we want to put it into descending order. X squared, subtract the 12x, subtract the 28. All over 4x. Now, just like we've done before, we need to make sure we factor. In order for us to do a lot of our work, we need to make sure we factor at this stage. So I'm going to put that in our notes. So if we were to factor this, we can see that this is a simple trinomial because there's the 1 in front of the x squared. The 1 times negative 28 is a negative 28, a sum of negative 12. So the only way that we get a product of negative 28 and a sum of negative 12 will be a negative 14 and a positive 2. So this entire numerator would factor as an x subtract 14 and an x add 2. A reminder, with simple trinomials, we can do this when there's a 1 in front. If it's a complex trinomial, we're going to have to do complex factoring. Now that we get to this stage, what we want to look for is whether we can cancel anything out. We do not want to cancel before. We also don't want to get rid of our denominator here until we have it factored. And that's actually going to be our next step. When we're solving this, typically we don't want to work with fractions too much. So what we can do is we can, at this stage, after we have factored, again, after we have factored, we can get rid of our fraction. So multiplying everything by that common denominator, multiplying the, actually, sorry, that doesn't look very nice. Multiplying this entire numerator by a 4x and this side by a 4x maintains that equality, because as long as I do one thing to one side and the same thing to the other side, I'm set. But a 4x and a 4x will be gone then. X subtract 14 and x add 2 would equal 0 times 4x. Well, 0 times anything is 0. Now that we're at this stage, we just set each factor equal 0. You could do this in your head, or as a reminder, you're setting each factor equal to 0. So in order to get the x by itself here, we'd have to add the 14. And on this one, we'd have to subtract the 2. So x would be 14, and x would be negative 2. Our non-permissible values, or our restrictions, are things in our denominator. Well, we technically only have 2 factors in our denominator. We have a 4, and we have an x. No matter where in our question we only have a 4 and an x. Of course, yes, we cross off here by that multiplication, but at one point in time we had the 4 and the x. 4 never equals 0, but x can equal 0. So as our restriction, we say that x cannot equal 0, and that's our only restriction. Now we're going to check our work. So what we're going to do is we're going to check each of these numbers in the original question. So we're going to check 14. We're going to plug 14 in for both of these x's. 14 over 4, subtracting 7 over 14, equaling 3. Is that true? Well, we don't have a common denominator here, so we can't subtract them yet. The beautiful bit with this one is that if we reduce this to be a 7 over 2, subtracting a 1 over 2, because both 14 is 4 divisible by 2, 14 divided by 2 is 7, 4 divided by 2 is 2, 7 and 14 are both divisible by 7, 7 divided by 7 is 1, 14 divided by 7 is 2. Now we have that common denominator, so we can subtract across the numerators. 7 subtracting 1 is 6. 6 over 2, absolutely is 3. So that means that x equaling 14 is one of our answers. It works. Now if we were to check x equals -2. So we're going to plug -2 into here. This will be a -2/4. Subtracting a 7 over a -2. Does that equal 3? Let's see. Still, we don't have a common denominator, but this one reduces. They're both divisible by 2. So it'll be a -1/2. And we see here that we have 2 negatives. Subtracting a negative. Well, in grade 7, when we were dealing with subtracting integers, we deal with the fact that the first number has to stay the same. Subtracting a negative, the way that I learned it was just that it's subtracting a negative is just adding. More than likely, a lot of the phrasing that seems to pop up a lot in grade 7 courses, that it's keep, change, change. So we're going to change both those negatives to be a positive. And if you take -1/2 and add 7/2, you get 6/2, which is 3. So 3 equals 3. Absolutely, that's right, which means that x equals -2 is a perfectly fine answer. So our two answers of -2 and 14 work. Next question looks a little bit more difficult, but in reality, it's not actually more difficult. I'm going to show you a little bit of a shortcut with some of our stuff because up here, I actually did a lot more work than I needed to. The first thing we want to do is see what are our denominators. Well, 3x over x plus 2, well, there's an x plus 2 there. This is a 5 over an x subtract 3, so our x subtract 3 is the denominator. Remember, those entire things are entire factors. You can't just say, again, you cannot just say that, oh, they have an x, this one would just need the -3, and this one just needs the positive 2. It's like, no. You cannot do that. What we want to do here is we want to check this denominator, aka factor it out. And I'm not saying factor it out, I'm just saying factor it. Well, it's a simple trinomial. With a simple trinomial, I'm looking for my product and my sum. Product of -6 and a sum of -1. The only numbers that give me -6 and -1 are -3 and +2. So since this is a simple trinomial, I just factor as an x subtract 3 and an x add 2. Now what we'll notice from here is that this fraction has the x subtract 3. This one has an x subtract 3. This one has an x plus 2. This one has an x plus 2. So this fraction has both of those denominators. Each of these ones only have one of them. Meaning, this fraction is going to need an x subtract 3. This fraction is going to need an x add 2. And then we distribute and combine like terms. The entire denominator is going to be an x plus 2 and an x subtract 3. In our numerator here, 3x onto x is a 3x squared. 3x onto a -3 is a -9x. Now I like adding a lot of subtractions in here to really emphasize the fact that when we're subtracting, you have to make sure you subtract. A shortcut skill is treat this as a -5. So when we distribute a -5 onto an x and a -5 onto 2, we don't have to do extra work. -5 times x is a -5x. -5 onto a +2 is a -10. I'm sorry, let's begin. I could change up the order, it doesn't matter. X add 2 and an x subtract 3. Now that our denominators are both the same, I want to, I'll combine two steps in one. What you'll notice on this left side is that I can combine these x's. Well, a -9x and a -5x would give me 14, or a -14x. But I need to get one side equal to 0 in order to solve. We need to get one side equal to 0. The shortcut to this stems from what we're doing here. On this one, we subtracted a 12x over 4x because we had the common denominator. If we already have a common denominator, all we have to do is just get rid of the numerator. Because essentially what we are going to do is we are going to get rid of something over, sorry, x subtract 3, not x plus 3. We're going to get rid of. So you may wish not to write this part, but we are going to get rid of this -25 over this x plus 2x minus 3. In order to get rid of a -25, we're going to add 25. But in order to save you a lot of work or a lot of writing, since I know that my denominators are already the same, all I have to do is work with the numerator. In order to get rid of a subtract 25, I just have to add a 25. But that only works when our denominators are the same. We need a common denominator in order to add and subtract. This is something that you definitely need to write. So if you understand this, all you have to do is add the 25 here and add the 25 there. Because it's implied that as soon as our denominators are the same, all I have to do is work with the numerators. Well, a -25 add 25 is 0. And 0 over anything is 0. On the left-hand side, I have a 3x squared, a -14x, and a positive 15 over an x plus 2, x minus 3. Now, just like the previous question, when we got to this stage where one thing equaled 0, we need to get one side equal, or we need to factor here. You must always factor first. You may be asking, oh, why don't we just get rid of our denominator right away? There is a specific reason. Factor first. I can't remember whether this question is the one that shows it more in-depthly or if it's the next one, but I do have an example that really, truly, fully emphasizes this skill as to why we need to factor this first. So a review of our complex factoring. It's a complex trinomial, which means we need to have a product of 3 times 15, which is 45, and a sum of -14. The only way that we can get a product of positive 45 and a sum of -14 is a -9 and a -5, which means that our complex trinomial will be split as a 3x squared, subtracting 9x, subtracting 5x, adding 15. Split it down the middle, factor from the first two, 3x, and an x subtract 3, negative 5, out of the next two, and we'd be left with an x subtract 3. And of course, if I wanted to write it again, I can factor out that x subtract 3, and I'd be left with a 3x subtract 5. So this entire numerator factors as an x subtract 3 and a 3x subtract 5. I am glad that I had the foresight to have this as actually that example. What you should see from here is that the numerator and the denominator both have that x subtract 3. So they're gone. This step would be optional. It is absolutely possible to get to the final step on this without writing this. I'll probably show that on the next example. But now that we've eliminated anything that's in common, now is the time that we can get rid of this denominator. So by multiplying both sides by an x add 2, that's gone. And we'd have 3x subtracting 5 equals 0. In order to solve this, add 5. And divide by 3. So our solution is that x equals 5/3. Our non-permissible values, our restrictions, are for our denominator. Well, even though we canceled off this x subtract 3, it's still one of our restrictions. X subtract 3 is 0 at 3. X add 2 is a 0 at negative 2. So our x cannot equal 3, and it cannot equal negative 2. Now, in this question, I don't show it as a check, or don't have it as a check, because I want to emphasize this bit here. So I want to do kind of a side note. If I went back to here, if I went back to this x subtract 3, 3x subtract 5, and the x add 2, and the x subtract 3 equals 0. All right. If by chance I got a little bit too trigger happy, and I decided, okay, I'm either here or even back to here, this 3x squared subtracting 14x plus 15, either of these steps, if I got to this stage and I said, oh, I'm just going to multiply the top and bottoms, or sorry, multiply both sides by the x plus 2 and the x subtract 3. X add 2 and x subtract 3. So that would eliminate those, that would be 0. We'd have x subtracting 3 times by a 3x subtract 5. And then we'd set each factor equals 0, so x subtract 3 equals 0, and 3x subtract 5 equals 0. Well, this would be x equals 3, and this would be still x equals 5 over 3. So we would say that our two answers are 3 and 5/3. If we go back to our restrictions, our non-permissible values, they were in our denominator, so the x cannot equal a -2 and a 3. Here's the problem. You can't say that you have an answer and something that can't be the answer in the same thing. You can't say that 3 is an answer, but yet 3 can't be an answer. It's impossible to have an answer and something that can't be an answer at the same time. So what should happen from here? Say what's a good color? And I'll just leave it with green. That can't happen. Well, actually, not that one, sorry. I'm actually going to undo that. Basically, we just say it cannot be an answer, leaving us with the only answer of 5/3. That is our only answer. If we put it as a solution set, it would be 5/3 in the solution set. In pre-calc 30, and probably by this time, a lot of them will be able to, doesn't matter which year I'm teaching this in, the timing usually lines up pretty well, that the grade 12s will see that this bit here is shown graphically on the pre-calc 30 side. So for those of you that in pre-calc 20 that want to take pre-calc 30, you'll see a little bit more as to what this looks like graphically, having this in the numerator and the denominator. But that graphing bit is left for pre-calc 30. So all that you need to know here is the algebraic solving, that we have one answer here, and then we have two restrictions, two non-permissibles. Okay. I wanted to add a trick question into here. Like always, I want to factor first. Well, x subtract 3 can't factor. Now, when I say factor, I really only mean factor the denominator, because we need to make sure we get a common denominator. This one has an x subtract 3, this is an x squared subtract 9, and this is a 1. So this is actually 5/1. But x squared subtract 9 is a special type of factoring. It's a difference of squares. So the square root of x squared is x. Square root of 9 is 3, making us have a positive and a -3 as our difference of squares. I wanted to put this trick question in here because right from here, right from this question, these x plus 3's can cancel off. Now the reason I'm canceling this one off is because there's an x subtract 3 and an x subtract 3 here. If by chance, so these ones will get canceled off, I'm just putting a hypothetical out there, that if this had an x plus 3, don't write this, but if this was x plus 3, this denominator would have an x plus 3, this denominator would have an x plus 3, and an x minus 3. It would be counterproductive for us to cancel these off if we would have to then still multiply it and get that x plus 3 back there. But this one doesn't have that x plus 3. This only has an x minus 3. Those two being the same. There's no other x plus 3's here, so we are free to cancel this off. Well, if we cancel it off, we're not left with 0. we're left with 1. Now that we have that x subtract 3 and that x subtract 3 there, I can kind of combine some steps here and just multiply this 5 or this negative 5 by an x subtract 3. So that will give us a 6 and an x subtract 3. On this one, we have a 1. Our only denominator is an x subtract 3. And then negative 5 onto x, negative 5x, negative 5 onto a negative 3, so positive 15. It doesn't matter which side we get to 0 because you notice that there's no x squareds. I mean, a negative x might not be your favorite, but it's going to save me a lot of writing if I just subtract the 6. Once again, and I repeat, our denominators are the same. So essentially what I'm doing is I am subtracting a 6 over x subtract 3. I'm just not writing the over x subtract 3 because the denominators are already the same. That puts the 0 on the left-hand side. And that's fine. You can have the 0 on the left. The last bit is to combine our like terms. There's no other x's, so it's a negative 5x. 1 add 15 is 16, and then subtracting 6 would be 10. Like always, when we get to here, now we're going to factor the numerator. Factoring the numerator, you can factor a negative 5 out. Well, there's nothing in common, so there's nothing to cancel off. But what I can do is just multiply both sides by that denominator to get rid of it. Because these would be gone. Now does negative 5 ever equal 0? No. But x subtract 2 could equal 0. More specifically, by adding 2 to both sides, x equals 2. Our non-permissible values, say we have this x subtract 3, so x cannot equal positive 3. But we can't forget that at the beginning, we still had that x plus 3 in our denominator, because x squared subtract 9 factors as that difference of squares. Just because we canceled it off at the beginning, it was in our denominator at one point in time. But x add 3 would equal 0 at negative 3. So we still have 2 non-permissibles. Now this one's actually a nice one, so might as well practice some individual skills. So the question doesn't ask for it, but it doesn't hurt to have some extra fraction practice. If we were to check this, we're going to plug 2 in for each of our x's. So we'd have 6 over 2 subtract 3. Here, we'd have 2 plus 3 over a 2 squared subtracting 9. Sorry, that was not correct. 2 squared, not 2 to the power 4. 2 squared, subtracting 9, subtracting 5. And then let's simplify. 2 subtract 3 is -1, so this is 6 over -1. 2 add 3 is 5. 2 squared is 4. Subtracting 9, we're going to subtract 5. 6 divided by -1 is -6. 4 subtracting 9 is -5. 5 divided by -5 is -1. And -1 subtracting 5 is -6. So since it works out, that means that 2 is the correct answer. One more. Emphasizes the skills. Three over x subtract 2. Adding 2 over x equals x add 8 over my first step. I'm going to factor the denominator. If I'm going to factor this denominator, it's a GCF factoring. I can factor the x out. By factoring that x out, I see that there's an x in these two, but there's not an x here. I can see that this denominator has an x subtract 2. This denominator has an x subtract 2. This one does not. I'll give you a hint, especially when you have different factorings like this, or like this. 99 times out of 100, this denominator is going to factor as these. This denominator factored as these two things. Pre-Calc 20 has these very specific skills that you need to learn and need to know how to do. There's not many trick questions to these, especially not when I show you that this is the only trick that you can do. If you can cancel off and it actually makes sense to cancel off, please cancel off. In this one, there is nothing that we can cancel off. We can't cancel off anything on any here because this is x plus 8. This is x and this is x subtract 2. So let's look at our denominator. We have an x and an x subtract 2. Both denominators are an x and an x subtract 2. This one is an x add 8. This one, 3 times x is a 3x. Adding, oh, adding's really nice to do. 2 times x. And 2 times -2. Oh, that's a -4. Since our denominators are the same, I'm going to want to get one side equal to 0 for me to actually solve this. And for me to solve this, I'm going to have to get rid of this x plus 8. So again, instead of writing the entire, getting rid of this over an x over, or x and x subtract 2, I'm just going to get rid of the numerator because the denominators are already the same. And here's another shortcut. Get rid of an x. How do you get rid of an x? You subtract it. How do you get rid of a plus 8? Well, you subtract it. You can do this because the denominators are the same. 3x add 2x is 5. Subtracting 1 is 4x. Negative 4, subtracting 8 is negative 12. X and an x subtract 2. Subtracting the x and subtracting the 8 here would leave us with nothing. You don't have to write this. It would technically be 0 over x and x subtract 2. But 0 divided by anything, as even the pre-calc 30s are directly dealing with right now, or very likely on any type of year that I'm teaching, it's going to be 0 regardless. 0 in the numerator means 0. Once again, do not get rid of this denominator until we have factored this numerator. Four, x subtract 3 over an x and an x subtract 2. Even though we see here that we're not canceling things off, you have to be wary of the chances that you're going to have something to cancel off. So you have to know when to do this. You have to know when you see it. So always err on the side of caution and factor here. Now that I see that there's nothing to cancel off, I'm going to multiply by an x and an x subtract 2. By doing that, x's will be gone, and the x subtract 2 will be gone, leaving me with just the 4 and the x subtract 3. 0 times anything is 0. So this even makes my life easier here, because I know that 4 never will equal 0. But x subtract 3 can. X can equal 0 at 3. Because I'm just adding the 3 to both sides. If you need to show the work for it, it's x subtract 3 equals 0. Add the 3. And that's how we get it. So we only have one answer. Our restrictions are non-permissible values. X cannot equal. Well, we only have the x and the x subtract 2. X can equal 0 at 0. And x subtract 2 can equal 0 at 2. And the question doesn't ask for it, but it doesn't hurt to practice our work with fractions. Let's check 3. We plug 3 in for each of these x's. So 3 subtract 2 plus 2 over 3 equals 3 plus 8 over 3 squared, subtracting 2 times 3. This is 3 over 1 plus 2/3 equals 11. I'm going to save myself a little bit of work. 3 squared is 9. 2 times 3 is 6. So I'm going to have 9 subtracting 6. Well, just like we worked with any of our other fractions, we need to get a common denominator in order to add. These two already have a 3 in our denominator. This is the only one that's going to have to be multiplied by a 3 in the numerator and the 3 in the denominator to get something over 3. Three times 3 is 9. Well, what's 9/3? Add 2/3. It's 11/3. Since that works, we know that our number works. as I love saying, when I deal with fractions with teaching at grade 9, grade 10, grade 11, fractions are your friends. And if you cut pizzas into 8 or more pieces, then you also have it as food. Right. And practicing. Good luck.